So as Jasmine said, I'm a UX strategist currently working at Digital Arts. And over the years, I've had kind of numerous other roles in kind of UX, sort of in production or producer roles and product management. But I spent a long time as a teacher and a researcher in a university in England, in the UK, teaching, figuring out stuff about the web, about mobile computing, and about games. And that's kind of where some of this pattern stuff comes out of, because apparently I'm mic'd up. Is that cool? Okay, and that's where a lot of this stuff, oh, there I am, that sounds better. And that's where a lot of this stuff comes from about patterns, because I spent a lot of time researching, working on patterns-driven projects, and even writing a couple of book chapters about them. So I'm going to, in the next 40 minutes, I'm going to try and cover about 50 years of design history and 50 years of patterns history. But kind of the first question is, why talk history, and why kind of even give this kind of presentation in the first place? And I think that's firstly because the term patterns gets used a lot. So lots of people kind of use that as a term to kind of just refer to stuff on the screen when they're trying to talk about kind of components or elements. But they're kind of really unaware of where that term originates and the kind of history behind it and why they might be using it. There's also kind of a lot of interest really now in design systems, and for good reason, because they're a really, really powerful tool and a really useful tool in business. I've had the opportunity to work on one recently with Auckland Council. And I think one of the interesting things about design systems is that the thinking and evolution of design systems has kind of really been driven by patterns and some of the kind of work that's kind of gone on with that. But patterns themselves and pattern thinkings are not actually design systems, and design systems are not patterns. However, there's a lot we can learn when we want to kind of implement and work on design systems, but also UX kind of generally when we kind of learn from the history of patterns. So the concept itself, has a long mixed history. And those who cannot remember the past are always condemned to repeat it. So rather than kind of forgetting about the mistakes and the issues that people kind of come on before, it's worth kind of like reflecting on that and learning from that. So yeah, as I said, I'm going to talk for about the next 40 minutes and try and cover about 45 years of history. So I'm going to go back to 1970, where pattern languages originated. I'm then going to kind of fast forward to the 90s and talk about object-oriented software design and how they adopted the use of patterns there. I'm going to talk about interaction design patterns and how they emerged in the 2000s. Then talk about design systems, kind of a little bit about that, which is a sort of concept that's emerged in the last sort of 5 years, really. And then kind of try and bring some of the kind of threads together from all of those kind of disparate, well, seemingly disparate pieces, and kind of figure out what we can learn from all those different implementations of pattern thinking and pattern processes. But first off, let's just go back in time. We're going to go back in time. So just to kind of get a sense of kind of people's understanding of history, because really kind of when we think about history is the stuff that's kind of happened after we kind of became aware of the universe and aware of what was going on, or before we became aware of kind of what was going on around us, stuff that kind of happened in our lifetimes, not really history. Stuff that happened before we were born or way before us, that's kind of history. So anyway, just as can I get a show of hands, who was working in digital before 2010? Most people, pretty much most people. Who was working in digital before, keep your hands up, who was working in digital before the year 2000?
Now we're old.
No. Now we can see that there's actually an awful lot of experience in the room. Was anybody actually working prior to 1990? We've got a few people. So again, we've got a lot of experience. Okay, so put your hand up now if you were born before 1980.
Fucking point.
I'm going to take us all the way back. I'm taking us back in time. So let's go back to 1970, where our story starts. So just to give you a bit of context. I didn't expect to get hecklers. I wasn't told we had to deal with it. Sorry? Okay, cool. Do you want to come and help? No? Okay. So let's go back to 1970, where my story starts. So just to kind of give you a bit of context, back in 1970 there was no real internet. Bits and pieces of kind of networks were being joined together, but they're all kind of really fragmented. ARPANET, which is kind of the daddy of the internet, was actually not to be implemented for the next few years. Email wasn't actually invented until 1972, and FTP was not invented until 1973. UX, or what we might now know as UX in the 1970s, was all about keyboards and green screens. So our story starts with this guy back in 1970, Christopher Alexander. Yes. So some people know Christopher Alexander. So he was working at Berkeley University in the 1960s. And in 1970, he worked on this thing called the Oregon experiment. And Oregon University decided they want to kind of rebuild their campus or rework their campus. We have some people from Oregon who have been to Oregon University and have been to that campus in the room, so that's cool. But yeah, so Oregon University wanted to kind of rebuild their campus because prior to 1970, it had been built quickly. It was this kind of small university in the middle of nowhere, effectively in Oregon. It was kind of filled with this kind of brutalist concrete architecture, and they had logging trucks basically going up and down the main street. And so the people that were kind of running the campus and wanted to redesign it wanted to kind of create a different and better campus. And then what they really, really wanted was to create, just to get some architects in, to not just create a new master plan, not just do a little kind of design a few buildings and then go away. They purposefully wanted an architect and an architecture team to design a process by which they could continue this development of buildings on campus and continue this kind of co-design process where they would get students and staff members, people that were working in the campus, to work together to design the buildings. So they hired Christopher Alexander and his team from Berkeley to create a new process for planning projects, not just creating the design for projects. So Christopher Alexander had spent the 60s working in and with developing countries. And he was really interested in how buildings get made. And he was really interested in kind of how buildings get made without architects, because most of the buildings in the world are made without architects involved, without professional designers. And if you look back to the 20th century, pretty much all buildings are built without any kind of architects. So how do they kind of get designed? How do they get made? How do people decide what it is they're going to build? And his best example that he uses for this is this kind of idea of the Swiss barns. If you kind of go and look across the hillsides in Switzerland, you look at a whole bunch of barns, they all basically look the same. When you go up close, they're not all the same. They're all slightly different shapes and slightly different sizes. Some are wider and some are longer, some are taller. But really, they all kind of look feeling much the same. And so he thought through the kind of design process that a farmer would kind of go through when they were going to design a barn or try to build a barn. And what they would do is they'd go and look at the barns around them. And so they would kind of like go, oh, that barn works, that barn works, that barn works. I like all those barns, and I'm just going to what I'm going to do is I'm going to copy the salient features of those barns and then create my new one. And I'm going to put it in wherever it is. It's going to be near my farmhouse or whatever. So it's going to be the kind of shape and size that it needs to be to fit next to my farmhouse. So I kind of need to make a few modifications. But effectively, what I'm doing is I'm copying the things that work from the other barns. So new buildings in this kind of traditional approach to design repeat the patterns of the old. So they use the patterns of the old, but they're adjusted to new conditions. So they use the kind of things that, for example, like Swiss barns, they use the construction materials that are there, they use the construction that kind of is appropriate for the environment and for their use. So that's where his concept of patterns kind of came from. And he wanted to be able to take a similar process of allowing lay people to design buildings and apply it to Oregon University and the Oregon experiment. And that's kind of where this concept of patterns was born. So the other thing that he was really interested in was, apart from kind of how people who are not architects build buildings, was why and how certain buildings and places just feel really good or feel nice or feel comfortable. What are the things that make a space really, really good? And this is kind of this concept of sort of habitability, which is a little bit like usability for architects. It's kind of like, how is the space usable? How does it make a person feel when it's in that, and so forth. But habitability kind of goes beyond kind of what we would kind of tend to think of as usability to kind of that kind of a whole bunch of kind of other emotive kind of aspects of kind of like, does that feel cool? Does it feel nice? And Alexander kind of came up with this basically came up with this concept because there was no words for it that he called equality without a name. There's this kind of thing that just basically a space feels awesome or a space feels cool. And there's no kind of real one word that kind of sums it up. So he kind of continuously called it equality without a name. It's kind of a space feels that's got an aliveness to it, as you can kind of see here in kind of in a kind of a public space. And one of the things that he saw about a lot of the spaces that had this kind of aliveness or this quality without a name is that they were never designed. They kind of evolved into being. They came into being. People were using spaces that were good and not using spaces that were bad. Those spaces would be patterns that people might copy or try and develop. And the interesting thing there that when he looked below the surface of it was about how human interaction shapes spaces and how that kind of social and physical interaction that goes on shapes spaces, and therefore shapes the architectural patterns he was looking at. And so when he came down to it, thinking about how you evaluate good patterns, the ones that you kind of want to reuse and reuse, is about the ones that have that quality without a name, that kind of have that aliveness. So you can kind of look at things that have that aliveness or that kind of coolness or awesomeness, and you want to copy those. And there wasn't any kind of like clear way to evaluate that. You just had to kind of go and look at them in use. So if we fast forward to 1979, and I'm not going to get anybody to pull up their hands. So it's the end of the Oregon experiment period. Just to give you a bit of context again, the internet is still fragmented in 1979. There is no internet. We're going to have to wait until 1981 for IPv4 to be published, and 1983 when ARPANET actually moves over TCP/IP, which is in 4 years' time, for the internet to truly be created. Because in 1983, it switches over to TCP/IP, and also domain names in the DNS system kind of come into place. So that's the real birth of the internet. So anybody here who was born before 1983 was born before the internet. Anybody born afterwards was obviously born after the internet. But anyway, let's get back to our story. Alexander in 1979 is written up as patterns and processes now. He's kind of gone through, spent many years working with Oregon University and with the staff and the students there to kind of create this process. And he wrote them up in the Oregon Experiment, Pattern Languages, and Timeless Way of Building. And so the interesting thing with the Oregon Experiment was that there was an incredible success. And the process was used then for decades to continue kind of how the university planned buildings and planned changes to the campus when Alexander and his team had left. So let's kind of go on to what patterns are, kind of what, how kind of Alexander sort of started to talk about patterns. So he described, each pattern describes a problem which occurs over and over again in our environment, and then describes the core of the solution to that problem in such a way that you can use the solution 1,000,000 times over without ever doing it the same way twice. And so I think it's kind of really interesting in that it's kind of got this core structure to what patterns are and how you apply patterns. It's a problem, it's got a solution to that problem, and the rationale for why, so the analysis of why it's working. So it's not just copying things and to taking various things and copying them for the sake of copying them. It's copying them because you know how and why they work. And interestingly, again, to sort of come back to his kind of concept of aliveness, he saw patterns as an attempt to kind of bring the deeper wisdom of what he called aliveness, that kind of quality, within any particular field of design endeavor. So he, sort of when he was writing this stuff up, he'd already seen that the concept of patterns could be applied to other disciplines beyond architecture. And he described sort of patterns as also sort of being these things that make explicit designs and design decisions that professionals would make or understand intuitively, but may not actually be able to kind of explain very well or explain to people. And so through this process of co-design that he was trying to create with Oregon University, he saw patterns as being a way to explain designs and design decisions and get architects and lay people who are not architects or designers, to start talking about design and be able to talk about design at a reasonably high level. I think one of the other important things in here about patterns and his particular way of viewing them is that he says that it's a solution that you can use the solution 1,000,000 times over without doing the same thing twice. So patterns are this kind of high-level concept. They're not a kind of they're not a specific plan or a diagram for something or a specific layout or whatever. They are a kind of generalized set of features or a generalized kind of schema for something. So patterns in that sense and kind of understanding, talk about patterns and using them as part of a process is really kind of generative kind of activity. So here's an example. And I think so in the pattern language, he documents 270 patterns that kind of go from the high level of things like city, country, fingers that talk about, I think I got your fly there. City, country, another one, I know, yeah. Almost flew in my mouth, but... Oh, there's it. So he talks about city, country, fingers, which is about urban planning, all the way down to things like ducting spaces, which is really about the detail of building infrastructure. And so this example here, he's got sunny place. So the problem is people only use open space if it's sunny, and they don't use it if it isn't anywhere but desert climates, obviously, because if you're in the desert and it's sunny, you don't really want to be in the sun. So the solution is to always place buildings to the south of the outdoor spaces that go with them, or the outdoor spaces they want people to use, and never to leave a deep band of shade between the building and the sunny part of the outdoors. So that might be just the shadow from the building or something like that. And they talk about evidence. So we have evidence that a deep band of shade between a building and the sunny area can act as a barrier and keep it from being used. So that's kind of, I think the sunny place is a really nice, simple example to kind of show what he's talking about when he's talking about patterns. He's not really talking about any specific implementation. He's not even talking about kind of a set of rules. They're kind of a very high-level kind of way of describing kind of how to solve a problem. And the particular implementation is flexible. He doesn't say you must do these things. He says this is kind of how you want to think about kind of how you might plan your outdoor space. So one of the other interesting things that he talks about or describes is how patterns are effectively an evolutionary balancing of forces. So as I was sort of saying is that the Swiss barns, it's not like somebody went out there and designed a Swiss barn and then magically they're all there and then everybody started copying them. Swiss barns were, or any kind of traditional kind of building or architecture like that, evolved. Somebody kind of makes small changes to things, they see how it works. If it works, then other people kind of like probably pick up on it and copy it. If it doesn't work, then it gets evolved out. And so patterns kind of look at balancing all those kind of various underlying forces that kind of go on or kind of social and physical forces that are kind of going on and competing. And they're kind of so they're physical responses to these underlying environmental forces. And so the world there is shaped by people and material and nature interacting. And I think a lot of the same thing goes for UX as well, and the same kind of thinking can be brought across from architecture to UX. So patterns then always have kind of a social and environmental context that they have to fit in. They have to fit in and with those forces that you that you're talking about. So like the sunny space example that we just had. In the northern hemisphere, it's a really, really simple example, but in the northern hemisphere, obviously, doors go to the south, and in the southern hemisphere, you want doors to go to the north. And so kind of just a really simple example of kind of that two different contexts. All of a sudden, you kind of get the rules, or the environment changes the rules that kind of need to be implemented. So the patterns was only one part of the picture that Alexander had for his process for redesigning stuff in Oregon University. The really important thing about it was about how patterns come together as a pattern language. So many patterns together form a language. So he documented 270 patterns of what he called a pattern language, which were kind of some generalizable things. And he recommended that sort of as part of this process is that the people who are working on the project work together to take some generalizable patterns and then look at whatever particular context you're in. So if it's a campus or a university, or if it's a hospital or whatever, you look around at good examples, those alive examples, those cool examples of whatever it is you're looking at, and you start gathering patterns from those. So other things that you can kind of see where they're common things, and then you form a project-specific pattern language for how that kind of works together. And he says a pattern language has a kind of a structure of a network. So the idea with the patterns is all the different pieces fit together and work together. So they interrelate to form the basis for a design. So a kind of description of how the design works or what it is, without kind of having to be really explicit about what it is. So without an architect, without having to kind of go and do building layouts or kind of say where things are, you can talk about what it feels like. And from UX, you can talk about kind of how products fit together without even kind of going near kind of a wireframe or trying to design a screen. So he sees the pattern language as really being a language. It's got a vocabulary, the patterns that kind of make it up. It's got a syntax, so those patterns fit together and how those patterns fit together and relate into a more complex whole. And it's got a grammar to it as well that describes the benefit that you get from bringing these things together. And if there is no kind of benefit from bringing these things together, then that thing or that pattern or that language or whatever that solution is shouldn't exist. So many years ago, I did a project with a startup called Beanbag. And it was an attempt to use a pattern language, to create a pattern language for them, for their project, that would kind of get a feeling for what the product did, what the site did, without actually having to really get into detailed requirements or getting bogged down in kind of doing interface design and working out that. So the important thing was how to discuss how things kind of actually fit together. And that's how the customer interactions would fit together with kind of the business. So you see in here we've got kind of we've got a lot of interaction patterns, but we also have kind of business model patterns that work with those and are justified by those interactions, or those interactions are justified by the business models. And so one of the interesting realizations here when we started doing this, obviously, was that this particular thing was far too complex, and they had far too an extensive ambition for launch. And one of the things we did kind of first off was how to cut that down and start talking about a really, really tight pattern language for what their kind of initial product was going to be. Cool, so pattern languages, Christopher Alexander's pattern languages, what are they about? They're about habitability, so how to make spaces that people are happy to live in. So who are patterns for in Alexander's pattern language? They're explicitly for both the inhabitants and the architects to work together on building something, coming up with a plan. Why do we use a pattern language process? And that's to engage the inhabitants with the process of architecture, with the process of design. It comes together in a language. So in that language is a network of relationships between all those kind of different patterns, that kind of network diagram of how they all fit together. And so how is it implemented? What's the process? It is actually a process as opposed to kind of an end product of collecting the patterns, working together and turning them into that pattern language for the project so you can talk about that project. So some of the interesting things we can learn from Alexander's work are that interactions shape spaces and spaces shape human interaction. And I think the same kind of goes for buildings and architecture as it goes for interactions in the digital space. One of the other things is the way that Alexander described patterns as being this balancing of forces. So understanding that patterns are not just here's what it looks like, here's the thing. They are a evolutionary balancing of a whole bunch of kind of forces, whether those kind of be social forces, business forces, behavioral forces, whatever. I think another really, really key thing, one that I've worked on projects to move pattern-based projects towards, is pattern languages as a project communication process, as opposed to a set of things that you just document. So it's a living, breathing thing. It's a process for communication. And the other thing is a pattern language is a generative system. So it's not just something that's kind of fixed, it's a thing that you can kind of use to create and further create designs. So let's fast forward to the 1990s, which most people are now familiar with. So in 1991, the World Wide Web was open to the public. If we're looking at the early 90s, HTML is still in version 1, they're working on version 2. If you want, you can browse the web via Mosaic. If you don't like text browsers like Lynx or Tim Berners-Lee's www. At the end of 1994, you can get your hands on Netscape Navigator, which was a kind of a big leap forward in browsers. IMDb, interestingly, was there on the web right from the beginning, but things like Amazon didn't come along until 95 and didn't take on till later. For lots of people on the internet at this point, the internet was America Online, and you're being charged by the minute for it. So the idea of using patterns as a way of talking about programming started kind of in 1987 when Kent Beck and Ward Cunningham presented this idea of kind of using patterns and pattern language as a way of talking about this kind of new form of programming called object-oriented programming that was kind of just beginning to kind of hit the business world. And I think one of the interesting things that I just recently found out about is that Kent Beck went to Oregon University, so at Oregon University in about 1980 or something. So he would have been probably in there and seeing Alexander's pattern language project and possibly involved in it as well. Kent Beck's also the guy that founded Extreme Programming, so he's one of the founders of the Agile Manifesto. Ward Cunningham. Anybody know what Ward Cunningham's famous for? Anybody? Nobody? Ward Cunningham's the inventor of the wiki. So he's also another Agile Manifesto founder, but he created wikis as a way, actually interestingly, of documenting patterns that they were finding that they were working on and that he was part of. And then in 1994, the so-called Gang of Four, which is Gamma, Helm, Johnson, Vlasides, wrote what's now recognized as a kind of a classic in software design, which is design patterns, elements of reusable object-oriented software. And this contains 23 reusable patterns that they had kind of collected and worked on across the previous few years. So just going to wind things back a bit. So what is object-oriented programming? Because some of you may know, some of you may not know, but I'm just going to read through some of this so I don't cock it up. OO programming is a paradigm based on the concept of objects which contain data in the form of attributes and code in the form of procedures, often known as methods. So that is, you have things with data in them, and then you can do stuff with those things with code. So programming is then actually about having those, how you get those data objects to talk to each other and interact with themselves and with each other. So for example, a web page has an object model, so JavaScript is an object-oriented system which contains that kind of object model within it. So if you want to kind of do something to get, say, a piece of data out of a particular element or change it, or you can use JavaScript to get data out of a particular element or change anything about it. So for example, you could put text into a form field, you could take that text out with JavaScript, you can lock it down, and you can send it to a web server. And the object-oriented language recognizes an element in a web page as being a thing that you can do stuff to. So the interesting thing is that object-oriented programming therefore has sort of this kind of abstract design, which is this kind of abstract idea of kind of classes and objects and methods. And so it foregrounds the design of the software, and that there's a design for the way that objects interact with each other and themselves. And that design can be abstracted from the code and can theoretically be then, whatever that design is, could then be implemented in any different language, though generally that's kind of practically not the case. And so because object-oriented programming has a come on. Is it going? Yeah. So because object-oriented programming has an abstract design, you can kind of look at in the design of the software rather than in the actual code that it has these kind of like patterns, these kind of patterns of relationship, and that's what these guys kind of recognized. And using Christopher Alexander's kind of concept of patterns, they started talking about a way of kind of like bringing those together. So they saw this object-oriented design patterns as being kind of this generally reasonable solution to commonly occurring problems within a given context in software design, which is very, very similar to kind of what Alexander was talking about in architecture. So here's an example here. And I always think one of the things about object-oriented software patterns is that they got that kind of really interesting weird names like decorators and abstract factories and things like that. Or this one here, singleton. So the problem being that the application needs one and only instance of an object. Why might that be? Because sometimes it's important to have only one. For example, if you've got a window manager or a file system with a print spooler, you only want one of these things. So you implement this kind of design that's up there, which that's a design in UML of how the classes look, that you've got a class which controls itself and it can only be one instance of it. For lots of us, it might not seem particularly interesting or particularly relevant, but for programmers, it's kind of really key and vital. So the book became massively famous, and Christopher Alexander, obviously being the kind of inspiration for this, was invited to a programming conference in '96. So he's an architect being invited to a programming conference. That's not actually very easy to read up there. But he said in a keynote speech that he gave there, which he'd been invited to, that he sees a format of patterns, the context, the problem, the solution, and so forth, had been copied, had been used. And then he says it allows you to write down good ideas in a way that can be shared and discussed, and it's become a useful tool in software design and has helped programming. And so he recognized that. However, that's not all that pattern languages were supposed to do. And he kind of goes on to talk about kind of what he did and kind of what pattern languages and software are trying to do. And the thing that the first thing he points out is he says, where are the users? Who's using this? You're designing this thing. I design pattern languages as kind of process for engaging end users in the architectural in the kind of whole process of architecture. What you guys are doing is you've taken some of those kind of ideas and all you've kind of got doing is documenting your own kind of process with it. So he said, where is the process of kind of co-design and collaboration that's kind of gone on? Where are the users in that? And I think this is interesting because it begs two questions about kind of one, who is software for, or who is code for, and who are patterns for. So to kind of bring that back to the same kind of structure I used to talk about the pattern languages. So what are they about? So object-oriented software design patterns, I think Christopher Alexander kind of missed this a little bit in understanding kind of what code was really about, is that object-oriented software design patterns are about readability. So how do you make code habitable by developers? Because they're the people that live in code. So who are these design patterns for? They are actually for developers, and they're by developers for developers. So they're the people who are actually kind of completely engaged in this process of using software design patterns. And so why use them? I mean, they are really used to just speed up development, kind of using tested and proven approaches to problems. And it kind of comes together just through a bunch of best practice. There are a smaller number of patterns. There's not really kind of many patterns in there. And the idea being that they are code agnostic or code abstractable design, reusable designs. And kind of a lot of the critics have just kind of pointed at them as saying that really what they are is just a set of tips and tricks. They are just here as a set of tips or tricks to implement in your software design. Here are some ways to speed you up. But I think we can still learn a lot from object-oriented patterns. And what we can learn from them is that first, they provide a format for documenting patterns. They kind of had a lot of detailed analysis of what patterns were about, and they start raising the question of, like, when we're talking about patterns, who are they actually for? Alexander was designing patterns, or started this journey with patterns, thinking about patterns being this kind of way of getting non-designers to work with designers. So let's fast forward again to the 2000s and interaction design patterns. So the year 2000 is gone. The Y2K bug has just come and gone. And there was a bit of a fizzle. There was a lot of excitement about that, but it wasn't really as dangerous as it seemed. No, yeah, the world didn't kind of collapse in flames. Everybody kind of kept on going. Google's just been launched and it's shooting to fame. There's no more Alta Vista. Does anybody here remember Alta Vista? Yeah. And we've just had the dot-com bubble and crash. So the dot-com bubble kind of happened in the late 90s, 2000, mid-2000, poof. Share prices wiped out, beginning of a mini recession. Lots of people losing their jobs. Exactly. It's true.
Why we're in New Zealand.
In San Francisco.
So, patterns were not new to UX, although they started to crop up sort of in the 2000s. So Don Norman and Stephen Draper's 1986 book on user-centered design talks about pattern languages as being kind of an inspiration for some of their work. The 1992 Apple Macintosh Human Interface Guidelines, which is I would say a seminal work on design systems. Back in '92, Apple said, this is how you are going to build Apple products. And that talks about design systems, talks about pattern languages and that, and patterns as a inspiration for what they do. And then it's kind of, in the early 2000s, a whole bunch of HCI researchers start to kind of apply patterns and this kind of pattern language to UX. And they're inspired by the work that's kind of going on in object-oriented or software design patterns and trying to bring it across into UX and seeing the work that, going back to the Alexander work and seeing how that was about design and about kind of the sort of deep philosophical kind of basis that Alexander had kind of created for patterns. And so these researchers are intent on creating websites full of patterns. So they started documenting patterns kind of wildly and sort of sucking stuff off the web as it was exploding. And so there's some great resources at the time in the early 2000s. So Martin Van Wheelie, Jan Borchers, and Jennifer Tidwell amongst them created websites full of patterns. And Jennifer Tidwell's book, Designing Interfaces, which is an excellent book which kind of collects together a whole bunch of patterns, was amongst them. And I think one of the interesting things about the work that was kind of going on in the 2000s was that it was kind of cross-platform. They weren't really necessarily worried about the web. They were looking at kind of bringing these generalizable patterns that would work across different interfaces and across different platforms and across different technologies and look at how they work. And then in 2007, the Yahoo Pattern Library was launched. And this, I think, kind of really brought this kind of approach of using patterns and documenting patterns to the fore. And this is a thing that I think that everybody kind of like, 5 minutes, okay. Hurry up. So what is an interaction design pattern? So they borrow from the structure of object-oriented patterns, and they borrow a bit from Alexander. So importantly, they have this structure that they've kind of really put in of a problem, a solution, and why it works. But whereas object-oriented patterns were quite abstract, and they could only really be understood by developers, because you had to kind of really get into the UML and the design of things. Interaction design patterns are actually really quite concrete. They usually have visual examples. They've got screenshots. They've got little pieces cut out and lots of little pieces there. So that people can intuitively see what's going on, both designers and non-designers. And I think it's this concreteness that made them really easy to use and kind of picked up really quickly. But it also introduces a few problems, which I'll come to in a minute. So here's an example of an accordion navigation. The user needs to look at a bunch of different things while staying on the same page. The solution is to stack the panels there and to open them and close them so you can show a lot at once. But it also kind of shows that there's a problem and that things can kind of get hidden inside that pattern. So it's this concreteness of showing an example and being able to talk about that kind of makes them really easy to use. But it's also a real problem in that people get stuck in exactly what they kind of look like. So the internet kind of got stuck, or the web design industry got stuck in documenting patterns and kind of lost the way that the patterns interact with each other and come together into a design. They've kind of lost that syntax and that grammar that Alexander was talking about with pattern language, and they're kind of missing that process of how you use patterns as a way to engage with end users and kind of engage in the process of co-design. So I think kind of two types of pattern library emerged across the 2000s. One were these kind of pattern collections, and the other was this kind of component library. So pattern collections are the things where the researchers are pulling together things from across the internet. And you get component libraries, which was like the Yahoo pattern library, where people are saying, this is how we're doing it, and bringing that together. So the pattern collections have common solutions from across a whole range of different sites or different products, whereas component libraries have these localized solutions and how they're doing it. Even if it's quite a big site like Yahoo, it's still this kind of localized, this is how Yahoo are doing it. The pattern collections are kind of based on evolutionary design. They're kind of looking at kind of what's working out there in this kind of big wide web where things can evolve. You can kind of pick out what has worked in an evolutionary sense. Whereas the component libraries are designed. They're kind of designed, they might be tested, but there's still kind of they're not an evolutionary process. The pattern collections are from all sorts of interfaces. The component libraries are from the site or this product or company. Pattern collections are generally code agnostic. And the interesting thing about component libraries, as they started to develop from the Yahoo pattern library, is that they actually contain the code within them. And it's the second wave that's kind of evolved into design systems. So pattern libraries are about usability. They're actually kind of for designers first, or have ended up being for designers first and users second. So why use them? They're generally repeatable solutions to common problems. And they come together in these kind of pattern libraries or collections. And they've tended to be implemented by being copied. So whether they're copied as standards or best practice or whatever, they just tend to be copied. So I think the things that we can learn is that rigorous documentation can be helpful to the wider community. They help kind of new people who are coming along look at, here's a bunch of kind of good practice or best practice. And I think one of the things that we can kind of really start asking ourselves when we're talking about pattern libraries, or what type of pattern library are we talking about? Are we talking about a collection of patterns from around the internet, or are we talking about a component collection that's around a particular product? I think the other thing is about all of this, the current use of patterns is that there is no process for using them. Compared with what Alexander set out, which is this kind of like complex process for how you use them, there's no process for how to use them. They're just dumped into websites. So it'll be 5 more minutes maybe, tops. So let's just go to beyond 2000. So I got this idea of atomic design, which Brad Frost came up with, which is about how you kind of make UI design systematic. And it's kind of, a lot of it's really based on the underlying modularity and reuse of code, of the tools that we use for actually building sites. And so the idea is that the atoms of the basic HTML, they go together to form molecules. So you can kind of put those things together so they form things that you can interact with. An organism might be something like a search box with your navigation and your logo. So you're actually kind of got something that can exist by itself and has multiple roles and multiple kind of interactions with it. And these organisms can fit into templates and grids that you kind of got, and they kind of form pages. So you can kind of break your site down into little pieces, and you can put it back together and kind of remix it. And through that, you can kind of do a lot of different stuff. So that's his idea. So design systems is everything that kind of makes up your product. So brand identity, the design language that talks about how things fit together. So for example, Google talks about kind of material as a metaphor, or how motion adds meaning. So there's kind of this language that talks about how they do design. It's the voice and the tone of your product. So how the content sounds, which really determines kind of what the relationship is between your user and your product. Style guides are kind of broken down styles on the visual elements that are in your site, which contain the code, the HTML that's in them, and the CSS. And then component or pattern libraries, which contain the kind of interactive components, the pieces that you can actually put together to build stuff. And these last two, interestingly, I think, over the last few years, live as code. So they're not just static designs, they're not screenshots from other sites and things. With design systems for a particular product, these style guides and component libraries live as code and often as production code. So there's stuff that you would actually have on your live site, and they're referencing the CSS that would be from your live site. So we've got examples like the Yahoo Pattern Library, Google's Material Design, BBC's Global Experience Language, the Lightning Design System. Lots of examples kind of cropping up in big products. So design systems, they're for efficiency. Really, they're about consistency and reuse. They're not for the same kinds of things that patterns and pattern libraries were for. Who are they for? They're really for your team. They're not specifically, first and foremost, for the end user. They're about making your experience cohesive, which is great for your user. But really, they're kind of generally first and foremost for making your teams more efficient and being able to implement things quickly, more efficiently with that design system, which is a set of parts and the practices that you have to kind of put those parts together. It comes together through design, through a whole bunch of code, and through the processes that you have to implement it. And they kind of form through designers and coders, iteratively rationalizing the system you've got through taking designs, putting them together, and rationalizing that. So 2016, it's all about design systems now. So just to recap, I talked about pattern languages and Christopher Alexander way back at the beginning, object-oriented design patterns, interaction design patterns, and design systems. And really, this is design systems, the thing that kind of we're really all interested in now. At least I hope we're all interested, and I'm interested in that. And that's kind of what we're about. So I just want to kind of bring some of that stuff together and the kind of context of design systems and sort of reflect on kind of what design system can take from the history of patterns. So that's all my kind of summary brought together, which is a lot of information on one side. But what the kind of really asks about is kind of like, what is your design system or your about? Why are you using it? Who is your design system for? Or kind of who are your patterns for? How do they come together, and how are they implemented? Oh. So I think there's three things I'm just going to finish up with. So patterns are a useful, really, really useful structure to talk about kind of design problems and design solutions. Pattern languages, I think, pattern languages are a process for co-design, which is in UX, I think, are kind of underexplored and underused, and could be used a lot more. And finally, I think, be thoughtful about how and where you collect your patterns. Be really, really careful when you're analyzing them, because there are a lot of anti-patterns out there. So there are commonly occurring bad solutions to common problems. So Burger, the kind of Burger navigation that we talked about, and it keeps coming up again, great example of an anti-pattern. Just because everybody else is using it doesn't necessarily mean that it's a good solution. And after a while, one of the interesting things is that everything can start looking like a pattern because you start seeing things everywhere when you're starting to analyzing things. Thanks.